right, so I'm going to show you two common techniques that you can use algebraically to find the limits with limit properties and things along those lines. So the first problem I'm going to work to kind of show you one common scenario is the limit as t approaches 0 of t squared plus t minus 2 over t squared minus 1. The other one's going to be the limit as x approaches 9 of the square root of x minus 3 over x minus 9. Now the first thing you always want to do with the limit, to be honest with you, is just take this number and plug it in. And look and see if you just get a number, because if you're just going to get a number, it's either going to be a polynomial or rational that's continuous at that point, which we'll talk about the continuity later on, meaning that that's going to be your answer just by plugging it in. That should be your first option. Your second option is if you get what's called an indeterminate form, which is what this is. Because if I plug 1 in here, I'm going to get 1 plus 1, which is 2, and 2 minus 2 is 0. And then 1 squared is 1, and 1 minus 1 is 0. So this is actually in a form of 0 over 0 if I plug in my 1. This is an indeterminate form. That's going to be a key that you're going to have to use algebra, some maybe trigonometry if there's trig functions in there, or later on in this year, L'Hopital's rule to actually find the limit. So what we're going to do is we're going to manipulate this with algebra and see if we can get out of this 0 over 0 trap. Now one thing I want to say for AP Calculus, you never want to write equals 0 over 0. You're going to lose points on the AP test if you write equals 0 over 0. But it's okay if you just write it out to the side 0 over 0 to remind yourself this is an indeterminate form and you're going to have to do some sort of algebra or trigonometry or possibly L'Hopital's rule to find the limit. So what we're going to do is, this is a rational function. I'm going to look right in here with the rational function. First thing I taught all my kids in Algebra 2 to do, and even pre-cal, is factor everything and see if anything cancels. Look, see if there's removable discontinuity. Now, also for AP and even for any calculus class, you want to keep carrying this limit down. You don't want to just forget about it and just throw it in on the last end. You'll lose points on the AP test. So we're going to do the limit as t approaches 1, and my top factors to x plus 2, x minus 1, and my bottom, well, what's the difference of squares? Why did I change it randomly to x? This should be t. Make sure you don't do that. And the bottom is going to be t plus 1, t minus 1. Well, hey, look, my t minus 1s, they cancel. These cancel out. So now I just have the limit as t approaches 1 of t plus 2 over t plus 1. Now, I know from here you could plug this in your head and get 3 out of 2, 3 over 2, but for the AP test, you've got to show the action of plugging this 1 into t. So we're going to get 1 plus 2 over 1 plus 1, and then our answer is just 3 halves. So the answer up here is just 3 halves, and that's our limit. Not terribly bad, just factors, stuff you've been doing in previous classes. All right, so let's look at this other problem over here. Another technique you can do besides factoring is rationalizing. And if I look here, I've got the square root of x minus 3, and I'm like, I could factor this and get rid of it, or I can multiply by the conjugate of my top, and that's what I'm going to do is I'm going to multiply it by the conjugate of the top. So remember, you've got to keep bringing your limit down. So we've got the limit as x approaches 9 of the square root of x minus 3 over x minus 9. But now I'm going to multiply it by the number 1. We're allowed to introduce things as long as we introduce it correctly. We can add 0 or we can multiply by 1. What I'm going to do is I'm going to multiply it by x plus 3 over the square root of x plus 3, and that was the square root of x, not x. So if I actually look at this, that's just 1. So even though I'm going to introduce something into this equation, I just multiplied it by 1. I didn't actually change the equation. I just made it look different. All right, so when I multiply my tops together, what's nice is we're using a conjugate in this instance, and I'm going to get x minus 9 over x minus 9 over, well, x minus 9 over x minus 9, the square root of x plus 3. Well, hey, look, my x minus 9s cancel out, and that becomes a 1. It does not go away. You have to keep that as a 1. It doesn't come become just the square root of x plus 3. Don't do that. That's a common mistake. And now I have the limit as x approaches 9 of 1 over the square root of x plus 3. And I can do the action of now plugging in my 9 because I no longer have my 0 over 0 form. So this is going to give me 1 over the square root of 9 plus 3. And at this point, you don't have to show your steps anymore. You can just do this arithmetic. And this is going to give me 1/6. So my limit here is 1/6. Now, we could have tried to plug 9 in right off the bat. And we would have seen that we've got 0 on top and 0 on bottom. And that's 0 over 0. And remember in AP, never write this as this equals 0 over 0. But it's okay to write on the side 0 over 0. So those are two common ways, two common techniques in which you're going to be able to manipulate your function here, your f, to find the limit by using algebra. But it's not it. You have to know all of the algebra you've been taught, and you have to be creative with it as well. So this is where the rubber really meets the road, and if you're weak at algebra, you're going to have to get a lot better really fast because it's no longer just a set way of solving a problem. You're going to have to try to think outside of the box to manipulate some of these to actually get it out of 0 over 0, this indeterminate form. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.